Okay, hello everyone, welcome back. I'm your friend XO. Today, let's get into the lecture 3. And to be honest, I found the progress of my learning in the mathematics is kind of slow. Let's try our best to say if we can make it quicker. Additive row, conditional probability. Product row. So this is what we're gonna learn. Additive row, conditional probability, product rows. What is that? So let's get into the first one. Additive row. Just at the beginning, I feel strange.
Additive rule.
Additive row. Alright, so now I know why I think it's weird. Because normally we would just say this word, aid. We would ignore that there also has another word called additive, right? But they are the same thing, I guess. Consider the corollary of whatever. It says maybe generalized by introducing. Oh, this is wrong. It should be introducing to an attribute number n of disjoint events. If the events A1, A2, An are multiply exclusive, Ai, uline Aj equal to an empty set, then the probability of their uline sum is equal to the sum of their probabilities. Yes, of course, if we assume that the I and the j, they are both numbers from 1 to n, and I does not equal to j, if the probability of I uline the probability of j, which means it could be every element inside of the whole set. If the uline of the two is equal to an empty set, then we would say the whole set, they are independent. In other words, we could just add all those probabilities together to get the probability of all. This may seem not intuitive, but that's the truth. So let's look at an example to get to know this rule, right? For example, a dish is toast. The events A equal to 1 or 3 occur, B even number occur. Okay, they are independent. Okay, let's say the assertion. What is the assertion? I think it's an assumption.
ASSERT. Assertion.
Assertion 1, all those probabilities, if we add those values together, we will get 1. That's something we all know. And then the probability of a thing plus the opposite of the probability is also equal to 1. This is also something that we are quite familiar with, so I don't want to waste time on this. And when you think about this, things start to getting complicated. So sometimes you thought that maybe the thing is quite easy, but it's not. You have to go through one by one. Otherwise, when you suddenly made this complex formula, you'll get shocked. You say, oh, why? Well, the reason for that is that you didn't go it slowly. You didn't walk through all those methods one by one. So you get stuck out somewhere. Alright, let's go on. Let's do it one by one. Sometimes when solving problems, it is convenient to find the probability of a complementary event and then to find the probability of the event. Well, you may not know the meaning of complements. It's something like if you got the whole number and if you got one part of that number, you could always try to get the complement, which is another part of that number, which aids the orange number equal to the sum. Something like that. Alright, now I could use a whiteboard to describe the word of complementary. Sometimes, for example, if they got an horizontal line and if they draw an angle, as everybody knows, this angle has a degree, or yeah, they have a degree of 180 degrees for this angle. And if we cut it into two parts, for example, something like this, and we call different angle x and y, then we will say the x and y, they are complementary. Something like that. So let us generalize formula on arbitrary events. let A and B be two arbitrary events, perhaps joined. For example, A times B does not equal to an empty set. Then we have A plus B equal to A plus B divided by A and B. Oh, why? Why this is even happening out there? Oh, now I got it. So basically, A times B, or the product of AB, does not equal to an empty set. That means, let me draw a graph for it. If we got an event or probability set of A and we got another set, let's say we call it B. The AB means the area. A times B means the area of both circles. This might not be a good example at all. Alright, now you understand the meaning of AB, where it's just the whole area of the A and B. Then what is B divided by the AB? Well, B divided by AB in the probability theory is just equal to B itself. So that's why A plus B equal to this. And you may still get confused by this because he said B equal to AB plus B. Why? When they do the plus, what do they mean? They mean this symbol, which is the U-line of something. And we both know if we U-line AB and B together, the intersect part would only be B. So that's why here we got the B out there. And we can even do more crazy stuffs with a formula transformation or something like that. Yeah, since we know the A and B, let's say they are independent. So the probability of A here plus the probability of B would be just equal to the possibility of A plus B together. And also, let's say what is this? Probability of A plus B equal to probability of A plus the probability of B and minus the probability of A times B. And we both know the A times B, as he said, does not equal to an empty set. Oh, I got it. From this graph, you would know the AB has no intersections, so since the probability of them is zero, that's why this formula exists. This is how they define that. The probability of the U9 of two events is the sum of their probabilities minus the probability of their joint occurrence. If you want to understand this sentence, you have to understand the joint occurrence first.
Joint occurrence.
Yeah, I was still confused by this. Why? The probability of the U9 of two events is the sum of their probabilities minus the probability of their joint occurrence. That's kind of weird. We may feel confused when we look at those formulas, but if we do it with another symbol, something like this, and everything would be more clear, right? The possibility of A U-line with a B is equal to the possibility of A plus the possibility of B minus the possibility of A intersect the intersection of A and B, right? Okay, this is more, let's say, intuitive or understandable than this one. This is so fucking inconvenient for us to understand. But as long as we transfer it to the form that we are familiar with, everything is okay then. So we need to remember the A symbol here always means the U9, and the times stuff always means the intersection symbol. Okay, fair enough. Now, yeah, that's correct. Let's go on. For now, we got this kind of formula. At the beginning, when you say such a thing, you may feel very confused and very hard to get started. You're like being shocked and you don't know how to do. You feel like you will never be able to master those things. So you quit. The learning of mathematics. But that's wrong. You shouldn't quit actually. Everything could be understood properly by human if you got a person like me that's willing to explain everything for you, or if you could find a good book that could explain that thing for you. If you can find such a thing or such a person, you're lucky, right? You have lucky. So the possibility of AI is just means any symbol, any variable. I don't care. It just means any variable or arbitrary variable. And what kind of variable? There has a lot of variable. For example, from the I equal to 1 to I equal to n, we could have, let's say, n's different variable out there. Then you could think the symbol right in here as a function. This function takes, let's say, infinity arguments, but for here, in a mathematics way, it has n's different variables out there. And we start from I equal to 1. And here, when you think about this kind of stuff, it represents those things out there. So they are the probability of each items. For example, here A and B, there are two items out there. And when you look at this formula, or when you look at this expression, it just means it's a sign. This sign could be a positive one, for example, plus, or it could be a negative one, for example, the minus symbol. Yeah, after that, and also you could look at those things as a whole stuff. It equals to this part. Alright, for more details, I won't cover it, but one thing you have to know is that it's not that difficult if you tried very hard to understand what's going on there. Conditional probability. The probability of A as a degree of objective probability of occurrence of event A is meaningful under a specific complex of conditions. If the conditions change, then the probability of event A can also change. What's that mean? Oh, so now let's say when you say this kind of stuff, this symbol, you should immediately have something in your mind. For example, if you read this sentence, the probability that A occur given that B occur. If you don't understand this sentence as I did, you could read the another sentence. For example, the probability of A given by B. So in other words, it's asking this expression. It's asking the probability of A if the B occur. So what's the probability of A when the event B occur? So when you hear this sentence, you should be quite clear what's the meaning of this. What's the meaning of this let's say expression? Alright, so let's continue. Let me explain it in a more specific way by drawing it out. It says that this means the probability of A when the event B occur. If we assume this bigger circle, the whole area of this is called the event B, then when the event B occur, what's the probability of event A? So they are identical. I hope you understand that. Okay, basically we have ignored this. Here we got a new concept called conditional probability. The probability A as the degree of objective probability of the occurrence of event A is meaningful under a specific complex of conditions. If the conditions change, then the probability of event A can also change. Let's add a new condition to the complex of conditions under which the probability of A is studied. The probability of an event A occurring when it is known that some event B, as the probability of the event B is greater than 0, has occurred, is called its conditional probability and denoted by something like this. Probability A and B. Sorry, not A and B. We should read it in something else. Oh, but how can we? No. Here, if we look at this website, it also has one called conditional probability. But they use let's say a different symbol, a vertical bar, to represent that. And it says that, oh, we could learn how to read this. Here we go. For example, for this stuff, we say this: the probability of B given that A has occurred. Alright, the probability B given that A has occurred. This is not a right sentence, as I think. This is equal to the probability of A intersection with B divided by the probability of A. Can you draw a graph for it? Let me try it out. So we assume this is A, and I'm going to use another corner to draw the B. And the whole stuff, we're going to divide it by the possibility of A. If we do that, this is the area that we're going to get. And as we have learned before, this is called the possibility of A when the possibility of B occur, which is exactly this area. For sure, I have no doubt about that. Oh, this one is a little bit tricky. You know, the B is at the first, but when he writes this stuff, he puts the B. He puts the B at the end of the expression. Yeah, I was really hoping that I could just screenshot this page. Then I work on this page with my another laptop so that I could use my electronic pen to do some drawing so that we could visually say how I solved those problems. But for some reason, my another laptop cannot receive an image. It can only receive text. So that's kind of boring for me to write the formula every time if I want to do an explanation. Alright, let's get into it. So the mission for me right now is to tell you why we could get this expression inside of the yellow box or original corner box. So we're told, since we have learned that the PA, let's say this stuff here means the probability of A when the event B occur. So it's also equal to A intersect with B divided by the probability of B. Well, you cannot doubt this, but because what's the probability of A when the B occur? That could only happen when both when both events occur at the same time. So that's why we use the intersect symbol, which is this one. And also why we divide the possibility of B? Well, because we only care about the event of A. So we're going to divide the B. And for this case, since we know the whole stuff, it's just another representation of A possibility of AB divided by the possibility of B. So in the end, it's just equal to, if you have noticed this kind of stuff, then we could easily write it down, something like this. Oh, that's very uncommon. We should try to do it in this way. Okay, when you see this, you may say, oh my god, why this is so complicated? Well, it's not that complicated. We could definitely handle it. So let's say if we want to put the denominator from the bottom to the top, how do we do that? We times the up and down version of it. So that will be n or n over nb. And in this case, the n, it's cancelled out. So in the end, we have left with NAB divided by NB. Yeah, that's exactly the correct answer. And everything else is just the same. I don't want to cover it anymore, but I should definitely know what's going on there. And for this one, I never see such a thing before. Yeah, but if you are smart enough, you would know if the possibility of A does not equal to 0, then we could just move this part up so that we could get this one. You know, they are the same, but we did some transformation for its components. Then we get this one. The problem is that you don't know why this stuff could ended up equal to this one. So let me work it out together. Let us work it out together. So PA is still there, but the possibility of B occur when, or the probability of B when the event A occur is equal to possibility of B intersect with A divided by the possibility of A. Well, this is equal to possibility of BA, that's for sure. But this leads us back to the original form. What's the point of this transformation? No, we had to get this one. Okay, so basically when you look at this, you would generally notice or you will realize it's not that hard as long as you could get the idea of that. When you say this stuff, you would say, oh, this means the probability of A when the B occur because we divided it by the B. And for this one, it's the probability of B when A occur because we divided the whole stuff with the possibility of A. That's the reason. And for each time, we'll get a different expression in here. But one thing is it's a scene, which is the probability of A intersect with B. This is a scene, so we could use it as an entry point to transfer some expressions. That's why you say that we get something weird here. So basically, the two writing here has no relationship at all. If you insist that they have a relationship with each other, then the PAB would be the one that could link this expression with this expression. Alright, let's look at into a real example. 3 cards are taken out without replacement from a well-shifted pack of 52 cards. Find the possibility that hearts do not occur. We could generalize the whole problem or the event not by just taking 3 cards out of that, but we take I cards out from the pack. So this is the definition for that event. So we had taken it 3 times. That's why we got 3 events. After we generalize that event, we used the 1, 2, 3 as a variable for this event's definition, so that we get 3 instances of that event. Oh my god, this is just like the programming, I guess. There has no difference with that. Okay, so let's go on. The probability of A1. Here we go. This is said that the heart does not occur, right? But here we calculate the probability that the hearts will occur. Why we do that? Because in the end we're gonna use a 1 minus that, I guess. I'm not really sure about that. No, that's not correct. Why they use the intersect? Because they want to make sure the 3 times, each time and all times, the heart does not occur. That's why they use the multiplication of probability, or if you prefer, this symbol, intersection symbol. And they try to, let's say, they try to calculate the probability of that by using the formula or expression that we have learned just earlier. At the beginning, it's a possibility of A1. We all know that it's just one certain thing out there. How about the A2? When you calculate the A2, you have to, let's say, the A2's probability, you have to divide it by the A1, which means the probability of A2 when the A1 occur. Yeah, of course, because this is let's say, continuous action. It's a continuous action. So that's why we do it like this. And when we do the third action, when we make the third action, we also do the same thing. Let's say the probability of A3 when the A1 and A2 they both happen. Of course, because this is a continuous action, right? So yeah, but one thing I don't know is that where he got those numbers. How he got those numbers. How do they get those numbers? For example, the 39. We know the 52 is the whole cards that we could have in a pack of cards, right? But where is the 39 comes from? All right, so probably I guess if you got 52 cards out there has 39 cards that does not have a heart. I guess that's why they use this number. And we could do it in this way, or as you could say, for each time the not occur card would be minus by 1. For example, 39, 38, 37. Why? Because this is the sampling without replacement, right? And also, instead of that, we could also find the probability by using the classical definition, which I guess is a smart way for doing that. Because let's say how he did that, how he calculated out the answer. Well, that's at the first he found out the combination numbers for taking 3 cards from the 39 no hearts card. That's the first thing he do. And the second thing he do is find out the probability find out the probability of taking 3 cards out from the 52 cards, which is a whole packet. And he did a division right in here so that he could get the probability of taking 3 cards out from 52 cards without having a single hearts inside of each of the 3 cards. This is a smart way. But by using this kind of thing, you have to at least know the formula of the combination, right? Do we really remember that? Oh, sorry. Let's say no, I don't remember that formula anymore. So I'm gonna go back. So here we go. This is without replacement, which is let's say the normal one. It's equal to the n factorial divided by the n factorial. I guess this is not the final one. We shouldn't remember this one. We should remember this one, and then the whole stuff divide the n factorial. Yeah, you may not understand what I was thinking about. Let me just print it out, or let me just draw it out. What I mean is something like this. Because for the combination, we should divide the possibility of duplicated numbers in the output or in the result. So that's why we divide the whole stuff coming from here. That's why we divide the whole stuff coming from here by the n factorial. So for now, you should be quite more, let's say, confident since you know the rules, and you just if you can remember this one, you could remember this one. You just add something to the formula, right? So this seems to be the end of this lecture. The next lecture is full, but I was kind of tired. So that's it. I'll see you guys in the next video, and I hope you enjoy this. If you didn't, well, I have no message for you. Probably you should go and watch a movie or a TV show or an animation to relax yourself, so that you could have a better feeling when you get started to learn something that really useful. By the way, the TV show and the movies or the animations, they are also quite useful if you want to have some kind of mental healthy. Alright, that's it. I'll see you guys in the next video. Bye.